Hi, I'm Dan. Let me show you the potentiometer and servo setup. So as I turn the knob, the servo moves. Alright. I don't think my potentiometer is working all that well. It's an old one. So let me pull this apart and show you what's going on. So unplug the Arduino. This is an Arduino Nano that Mark talked about. It's the same as a normal Arduino, just smaller. All the same pins, everything's the same. It's just smaller. I'm using this breadboard, just makes it slightly more convenient. Anyways, here's the potentiometer. And essentially, this is a resistor, 10 kilo ohm, 10,000 ohms, from this pin to this pin. When you move the knob, this middle pin changes its resistance between that one and that one. So as you move it this way, the resistance here becomes 0, and the resistance here becomes 10 kilo ohm. When you move it the other way, about halfway, it'll be 5 kilo ohm to each, from here to here and from here to here. And continue turning it all the way, it becomes 0 ohms across here and 10 from here to here. The trick here is we put 5 volts in here, ground or 0 volts here, and we send this pin off to the Arduino, and it can measure that voltage and as a sensor. So I'm just going to put it in the breadboard. You can just hook the wires straight to it if you want, but I'll put it in the breadboard. Oh, these pins are quite big, I have to push that in quite hard. That could be a source of my problems. Alright, the servo, I had to look up the wiring. Brown is ground, red is 5 volts, and yellow is the PWM signal, the signal from the Arduino to tell this which direction to turn. Alright, and because I'm using the breadboard, I've got a whole bunch of hookup wire. So there is 5 volts coming out of the Arduino on the 5 volt pin. On the Nano, it's that one there. Just read the labels, and I'll take that straight to the potentiometer on one side of the pins. I'll also hook up the ground again on the Arduino. Just read the labels from ground to the far side of the potentiometer. And if we look at the code, I'll tell you, in Arduino, then it's pin 0, analog pin 0, and I'm using yellow for that, and it goes from the middle pin on the potentiometer. My breadboard's falling apart. To A0 on the Arduino. Now we could test this immediately, but we'll just jump right ahead and wire up the servo with the example code that we've got. So we need another 5 volt. I can either plug it in here at the same point in the Arduino, but I can also just take it from here. Because there's a wire, it's the same point really. So I'll just take it from there and put the red to the red 5 volt. This time I'm using brown for ground. Plug that one in next to that ground. Plug it in brown to brown. And then finally the orange wire, the code says servo attach 9. So I'm going to find pin 9 on the Arduino. That one. Hook it up to pin to the orange one. Plug my Arduino in. And of course it's already programmed with that example code. Oh, now this Arduino's got a little problem. When I plug it in, when everything's wired up, the computer doesn't recognize it. I don't know why. This is a very old Arduino that I'm using. So I'll just pull the ground out of that circuit. That sort of disconnects everything. I'll plug the Arduino in. Proper sounds from the computer. Now I'll put the ground back in. I can upload the code and it doesn't go, of course. It's probably just I might upload that code. Didn't expect to hear that sound. I might unplug that ground again. I think I've got a loose wire somewhere on my breadboard. Let's try that again. Upload. This is done. Plug my ground back in. Still got power. It was working before. I would say it doesn't like that resistance from power to ground. But really, I thought it should be fine. Or maybe it's my dodgy USB cable. Alright, I'm going to troubleshoot that and get back to you. Alright, turns out I had a crook Arduino. I think it was originally a knockoff. I think it's a knockoff Arduino, and it's probably 4 years old. It's been sitting around in a drawer for a while. But anyways, we're back to it working just fine. I haven't changed any of the wiring, and away it goes. Now I'll show you a advanced technique. You can see what's going on the software side of it. Let me hop to the screen recorder. Alright, so this sketch is located under File, Examples, Servo-Knob. Now, this by itself operates what you saw in the video, but I'll show you a way to debug some of this, see what's going on under the hood. Let me quickly go over the code just to tell you what's going on. This line here, #include servo.h, brings the servo library into the sketch. There's many libraries available. for Arduino here, include library. And you can go to manage libraries, search for new libraries, add new libraries, and so on. In fact, you can even see the servo one there. Servo my servo. You can call this my servo anything you want. It's a variable name. It happens to be called my servo, but you can call it servo 1, servo 2. You can set up many of these if you want. These are just variables, in this case integers, and they're just useful for holding values. In this case, the potentiometer pin is 0. So it's talking about analog pin 0. And this val value is just used later on. This section of the code, void setup, is the one that is run once when the Arduino is first turned on. And so you just need to attach the way that the servo library works is you have to attach a servo to a pin, in this case pin 9. So if you didn't want to use pin 9, that's where you would change it away from pin 9. You'd choose pin 1, pin 8, 10, whatever. Okay, void loop is the part that goes over and over and over and over again forever. So here we're using that variable value, and we are doing an analog read on the potentiometer pin. So analog read means read a voltage somewhere between 0 and 5 volts. That was what we were doing with the potentiometer, was sending some voltage between the 0 volts ground and 5 volts. Map, then we shift the value again. Map is a maths command which takes stores the result in value, so it overwrites. It uses the old value. Stores the result in value. That's the input from the analog read. So a voltage of 0 will be 0, a voltage of 5 volts will be 1023. Let's say exactly halfway, 2.5 volts will be 512, or 511, somewhere around there. And then the output of that number will be between 0 and 180. So 0 will get mapped to 0, 1023 will become 180, 512 will become 90. That new value of val is then written to the myServo object with the write command, and then delay 15 microseconds, and then do it again. So read the potentiometer, change the values, write it to the servo, wait 15 milliseconds, and do it again and again and again, and it updates the servo position. So if we wanted to see if the potentiometer was going, if the servo was not going, we might want to split the problem in half. We want to see if the potentiometer value is even getting into the Arduino. So you can't overwrite examples, so I'm going to go save as, and I'm just going to put this on my desktop. Alright, now I can make changes to the code. Alright, so to use serial in the setup, we will just type serial.begin 9600. So that starts a serial port at 9600 baud rate. And here we will serial dot print pop value serial.print print ln for print line, so it does goes to the next line after it. Val, no quote marks. And now, is this going to show up on the video? No. Just need to fix my video recording. Okay. Right, let's close that window and start again. Right, so this button over here, serial monitor, opens. I'm on Windows, so COM9. Same as the Arduino. This one is set to 9600. Remember, we typed that in one in code. I'll turn that off. And now, let's make my window a bit smaller. Okay, now when we upload this new code to the Arduino, here we go. We have values of 189 scrolling past. If I move this potentiometer, you can see the numbers changing. So I know for a fact that the analog read pot pin is working because I'm getting these values. Now I could also print out the value after it's been mapped, but that's just academic, really. And so if this bit is working, then your potentiometer is working, and the problem lies in the wires or the servo itself. So if it's still not going, maybe try changing the pin it's attached to. Double check your wires. If you've got a multimeter, make sure that the servo is getting its 5 volts. Alright, best of luck.